Hi there. Okay, we're going to talk about forces. And a force is a push or a pull on something, right? There are two types of forces. We can say there's static forces on something that's not moving, like wind pushing on a building that's not moving, or the weight of the building, or if you're holding something, that would be static. Dynamic would be on something that's moving, for example, an engine pushing a car, right? Okay, now when we draw forces, we represent them with arrows. The fancy word for that is vectors. And we can add them. Okay, so we're going to look at a real example here. Let's get started, okay? So here's Mindy. She's driving her fancy car. Woohoo! Okay, actually, that's not that fancy. Let's get fancier. Okay, yeah, that's it. So Mindy's driving her car. Unfortunately, car breaks down. Mindy calls somebody over and says, "Hey, buddy, can you help me?" Okay, buddy comes over, helps. Yeah, the size is a little off. Comes over and helps because Mindy has to push the car. So if she's pushing this way with a force of 9 and he's pushing with a force of 6, okay, they're pushing the car along, you would obviously add those forces to find out how much force the actual car has, right? So let's look at this on paper. On paper, it was going the other way. Mindy is pushing with 9, he's pushing with 6. The total force would be 9 plus 6 is 15. And lastly, look at the length of the arrows. The length of the arrow represents the strength of the force. So if this is 9 and I want to add 6, it would probably come to around there. I'm going to draw that force over here, and it should be actually quite long, right? Because it represents 15.0 newtons. The unit for force is newtons because the scientist Isaac Newton, figured all this stuff out. Okay, that makes sense, right? Now, Mindy, unfortunately, is driving her car along again, breaks down, and she calls for help. Oh boy, I don't want to push this all on my own. So she's all there. There it is. The car doesn't work. And she says, "Hey, buddy, yeah, can you help me push?" So I says, "Sure." So she has to push the car. They get started. And unfortunately, this guy's not from Rosemount. He's pushing the wrong way. Okay, and as they're pushing, they're canceling each other out. What is up with this guy? Anyway, they're canceling each other out. The car's not going to move, right? So the direction of forces matters. So when we're looking at forces, okay, if they are in opposite directions, we have to subtract them. Let's look at this. If somebody is pushing in this direction with 8 newtons and somebody else is pushing that way with 2 newtons, this force is not helping that person. It's actually canceling it out. So when you want to draw your answer, you're going to do 8 minus 2 is 6 newtons. And in which direction? Well, this person is obviously winning. It's a stronger force. So it's going to go in that direction, and it's going to be 6 newtons. And when I make the line, it should be less than the 8 newton line, but larger than the 2, right? So let's do it something like that. 6 newtons. That is the resultant force of adding those two. What does that mean? It means if I have my car here, okay, and Mindy's pushing with 8, and Smarty Pants here is pushing with 2 this way, I could replace both of these forces with just one person that pushes that way with 6, and the car would move the same way because the 2 is canceling out 2 on this side. So those two forces, 2 people pulling this way, is the exact same thing as one person pulling with that force. Okay? Nice car, huh? Okay, so you should see that you can, if they're in the same direction, you're going to add them. If they're in opposite directions, you're going to subtract them. Okay, so let's look at this. In this case, we would have 4 plus 2. We redraw the box, and it would add up to 6.0 newtons. This, redraw the box, and it would be pretty long. I'm overlapping, but it would be about 15.0 newtons. and so on. I have 3 in this case. Well, 2 plus 4 plus 1, 7 newtons. Going to this, they are going in opposite directions. So I'm going to subtract them. 7 minus 5 is 2, and the winner is this one. 10 minus 6 is 4. I'll write it beside. And 4 going up. And the last one, oh, I have 2 that add and 1 that subtracts, right? So that is the same as 10 newtons, and that is 6. So my answer would be 10 minus 6, 4.0 newtons. Last thing you need to know about forces is when you add the forces, they add up to 0. That's a special situation. So in this situation, I have 7 pulling this way, 7 pulling that way. They're going to, when I subtract them, 7 minus 7 is 0. If I redraw it, 0. I can write 0 newtons. I don't need an arrow. This is special because it means it wouldn't move. We say it's at equilibrium. Okay? So when the forces cancel out to 0, we say the object is at equilibrium. Okay? So there you go. That's forces. And if you ever need to help somebody push their car, make sure it's the right way. Ciao. You didn't help me at all.